Look up at the night sky for a moment. Really take it in. At first glance, it feels simple, almost empty. A vast ocean of darkness, dotted with a few scattered points of light. It's quiet, still, and strangely calming. But that simplicity hides one of the deepest mysteries humanity has ever faced. Because if you stop and think about it, the night sky doesn't make sense. The universe is unimaginably vast. It's filled with stars, hundreds of billions in our galaxy alone, and far more beyond it. So here's the question that has puzzled scientists for centuries. If the universe is so full of light, why is the sky dark at night? Why isn't every inch of it blazing with brightness? This question is known as Olbers Paradox, and for a long time, it wasn't just a curiosity. It was a full-blown cosmic mystery. It challenged everything we thought we understood about the universe. It was like staring at a crime scene where all the clues contradicted each other. The expectation was simple. If the universe is infinite and eternal, then no matter where you look, your line of sight should eventually land on a star. Imagine standing in a forest that stretches forever in every direction. Even if the trees are spaced out, your view will always be blocked by one eventually. There's no such thing as an empty line of sight. Now replace those trees with stars. If the universe worked that way, the entire sky should be filled with light. Every tiny patch should glow as brightly as the surface of a star. Night wouldn't exist. Darkness wouldn't exist. The sky would be a continuous sheet of blinding brightness. But it isn't. Instead, we get darkness. Deep, overwhelming darkness. And that contradiction sat unresolved for generations. In the early days, astronomers tried to explain it with what seemed like a reasonable idea. Maybe something is blocking the light. Perhaps vast clouds of cosmic dust were absorbing it, preventing it from reaching us, like fog, obscuring headlights on a distant road. At first, this seemed promising, but it didn't take long for the flaw to become obvious. Anything that absorbs light also absorbs energy, and when something absorbs enough energy, it heats up. Eventually, it has to release that energy again. That dust wouldn't stay dark. It would glow. Maybe not in visible light, but in infrared or other wavelengths. The sky would still be bright, just in a way our eyes couldn't detect. So the dust explanation collapsed. The mystery deepened. It became clear that the darkness wasn't just an absence of light. It was a clue. A signal that something fundamental about the universe was different from what we assumed. The breakthrough didn't come from studying darkness directly. It came from understanding light itself, and more importantly, understanding time. The first major piece of the puzzle was the realization that the universe has a beginning. For a long time, people assumed the universe was eternal, that it had always existed and always would. But modern cosmology changed that completely. The Big Bang Theory revealed that the universe is about 13.8 billion years old. It had a starting point. That one fact reshaped everything. Light doesn't travel instantly. It moves at a finite speed. That means when we look into space, we're also looking back in time. The farther away something is, the longer its light takes to reach us. Now think about what that implies. If the universe is 13.8 billion years old, then light from objects farther than 13.8 billion light years away hasn't had enough time to get here yet. Those regions exist, but they're invisible to us. Their light is still on the way. This creates what we call a cosmic horizon, a limit to how much of the universe we can see. Suddenly, that infinite forest analogy breaks down. The forest might go on forever, but we can only see a finite portion of it. Beyond a certain distance, it's simply too far for light to have reached us. That explains part of the darkness, but not all of it. Even within that observable region, there are still countless stars and galaxies. enough in theory to light up the sky completely. So why doesn't that happen? The next clue came from a discovery that completely changed our understanding of space itself. The universe isn't static, it's expanding. This was a revolutionary idea. It means that space itself is stretching, carrying galaxies along with it. They aren't just moving through space, they're being pulled apart as space expands between them. And this expansion has a strange effect on light. As light travels through expanding space, its wavelength gets stretched. This phenomenon is called redshift. The longer the wavelength becomes, the lower its energy. Visible light, the kind our eyes can detect, can be stretched into infrared, then into microwaves, and eventually into radio waves. At that point, it becomes completely invisible to us. So even if a distant galaxy is emitting enormous amounts of light, by the time that light reaches Earth, it may no longer be visible. The sky isn't empty. It's glowing in wavelengths we simply can't see. This realization transformed the mystery. Darkness wasn't just the absence of light. It was the presence of light beyond our perception. A hidden glow stretched across the cosmos. Still, even with these insights, the puzzle wasn't fully solved. There was one more piece missing, and it turned out to be the most surprising of all. For decades, astronomers tried to estimate how many galaxies exist in the observable universe. Using data from powerful telescopes, they arrived at a number that seemed almost unimaginably large, around 100 to 200 billion galaxies. It sounded absurdly huge, but it was wrong. In 2016, a team of astronomers took a deeper look. Instead of just counting visible galaxies, they analyzed vast amounts of data collected over decades. They reconstructed the universe in 3 dimensions, effectively turning observations into a timeline, a way to look back through cosmic history. What they found was astonishing. The early universe was far more crowded than it is today. Galaxies were smaller, more numerous, and packed much closer together. Over billions of years, many of them collided and merged, forming the larger galaxies we see now. In other words, the universe didn't just contain galaxies. It evolved, constantly reshaping itself. When the researchers accounted for all those ancient, faint, and merged galaxies, they arrived at a new estimate. Not hundreds of billions, trillions. At least 2 trillion galaxies exist in the observable universe, and possibly even more. This discovery changed everything. It meant that most galaxies are not easily visible. They're too small, too faint, or too distant. Their light is either too weak or too redshifted to detect with traditional instruments. In fact, roughly 90% of galaxies are effectively invisible to us. Think about that for a moment. Everything we've ever seen, the stars, the galaxies, the deep field images, is just a fraction of what's actually out there. We've been looking at the universe through a narrow window, unaware of the vast majority of its contents. Now, when we return to the original question, why is the night sky dark? The answer becomes clearer. It's not just one reason. It's a combination of 3 profound truths. First, the universe has a finite age. There hasn't been enough time for light from the most distant regions to reach us. Second, the universe is expanding. Light from distant galaxies is stretched into wavelengths we can't see, effectively hiding it from view. And third, most galaxies are faint and distant. Their combined light simply isn't strong enough to overcome the effects of distance and redshift. Together, these factors create the darkness we observe. But that darkness is deceptive, because behind it lies an incredibly rich and dynamic universe. Modern telescopes are beginning to reveal this hidden reality. Instruments designed to detect infrared light can see galaxies that were once completely invisible. They're uncovering structures that formed billions of years ago, ancient systems that existed when the universe was still young. Each new observation adds another piece to the puzzle, and with every piece, the picture becomes more extraordinary. What once looked like emptiness is now understood as abundance. What once felt like isolation is now recognized as immersion in a vast cosmic network. Even the smallest patch of sky, something that looks completely blank, can contain thousands of galaxies when observed with the right tools. It's a humbling realization. With the naked eye, we can see only a handful of galaxies. But that limitation isn't a reflection of what exists. It's a reflection of our biology. Our senses are tuned to a tiny slice of reality. The universe, by contrast, operates on scales and in forms that go far beyond human perception. So what does it mean to live in a universe where most of reality is hidden? On one level, it's deeply humbling. It reminds us that our understanding is incomplete, that there are vast realms we've yet to explore. But on another level, it's incredibly inspiring, because it shows that discovery is still possible. The fact that we were able to solve a mystery like Olbers Paradox, that we could take a simple question about the night sky and uncover such profound truths, is a testament to human curiosity and ingenuity. We didn't just answer the question, we uncovered an entire hidden universe in the process, and that changes how we see everything. The night sky is no longer just a backdrop. It's a story, a record of cosmic history written in light and shadow. Every dark patch is filled with unseen galaxies. Every point of light is a reminder of something vast and distant, and every observation is a step closer to understanding the whole. In the end, the darkness of the night sky isn't a sign of emptiness. It's evidence of something far greater. It's the imprint of the universe's beginning, the signature of its expansion, and the shadow cast by trillions of galaxies, most of which remain hidden from view. So the next time you look up at the stars, remember this. You're not looking into a void. You're looking into a universe that is richer, deeper, and more crowded than you can possibly imagine. And the darkness. That's just what it looks like when infinity is still revealing itself.